Hello, so today we are going to do this problem, which is part of Leetcode September Daily Challenge. It's find original array from doubled array. So the problem says we get an original array, and this array we want to transform it into a doubled array, or this array actually was transformed. So suppose it was transformed to a doubled array called changed, and what we get as a parameter is actually the changed array. Okay, and the transformation that we do is we append twice the value of every element in the original array. So we append it as in not addition, like 1 plus 1 equals to 2, but more like in the list appending. So if it's like just 1, then we will append 2, right? 1 multiplied by 2, so we'll append 2, so we'd have 1, 2, array of 1, 2. And then we randomly shuffle the resulting array, and that's what change it is. It's the transformation is appending twice the value of every element and then shuffling, right? And the goal is, given that this changed array, we want to return the original array if actually it was a result of this transformation. If it wasn't a result of this transformation, we want to return an empty list. And so if we take a look here at the first example, you can see 1 multiplied by 2 is 2, 3 multiplied by 2 is 6, 4 multiplied by 2 is 8. So this is actually a doubled array, and the original array is 1, 3, 4. And then for each one of them, we doubled it and then appended the result of that. Okay. So the first example looks good. For the second example, if we take this, it's actually not a doubled array, because even if you sort it like you would have 0, you would have 1, and then you would have 3, 6, and you can see there is, like, if you take 0 and 1, which is the first small portion, this is not a double of it, so it's not actually a doubled array. This one is just one element, so it's impossible for it to be a doubled array, because for a doubled array you need at least 2 elements, right? You need actually like an even length. Okay. So that's the problem. Now how do we solve it? So how do we solve this? So the first observation to think about is that, well, if it was a doubled array like this one, then we can take the smallest element and be able to remove it and then also delete its double. Or even more generally, we should be able to take each element and delete it and delete its doubled array, and then at the end we will end up with an empty list after doing that, because if it's a doubled array, then every element should have a double. If we end up with a non-empty list, that means it's not a doubled array. So that's the first observation. The second observation is, which element would have a doubled equivalent? Definitely like the smallest and divided by 2 elements, right? Because if it's doubled, then half of it is the original array, right? So if it's doubled, that means half of it is the original array, right? And the most likely to be doubled is the smallest element, right? Because if you take a big element, if that's the bigger element, if you multiply it by 2, you won't find that value, right? And so you can see it even like in this example that we have here. If you take, so let's say you take the smallest element 1. If we multiply it by 2 and the element is not in the array, well, certainly that means this is not a doubled array, right? Because since it's the smallest, there should be, by definition, it's double, right? And so that's the second observation, is to kind of approach it from the smallest element. And so what we can do is just keep doing that, basically keep getting the smallest and try to remove its double until we remove everything, right? So take smallest, remove it, and remove its double, which is, and each time take the next smallest until you process all the array, right? So how do we take the smallest, right? Now that becomes the problem here. Well, we can just sort the array and then go through it, right? But how do we easily remove, right? We don't want to do like a list.remove, because that's an expensive operation, that's O of n. So the easiest way to remove quickly is, instead of having the array represent these values, let's have an occurrence map or a counter. And then each time we remove, we just subtract the number of occurrences, right? We may have duplicates, so we want to record the number of occurrence. And each time we want to remove, let's say, the smallest element number, we'll do subtract -1. And to remove its double, because we just processed it, right? We'll remove also the number multiplied by 2, right? And that's pretty much the idea here. Okay, so let's start doing this. So the first thing we need is we need to have occurrences of all the numbers. So let's, you can use a map, but I'm going to use Python counter because it's easier. And then we will have the result array that will append element 2, and so return result. And then we'll go through the numbers in sorted order. I'll rename this to nums, right? Okay. And then we want to check if the number here is present, which means we haven't processed it before, because maybe, let's say, if we are looking at this array here, right? Once we get to 3, in our occurrence, 3 was equal, 3 had occurrence of 1, right? So we had 3, 1, and we had, for example, 6, 1, and then we have the other elements, right? So once we are processing the number 3 here, we'll remove 3, we'll set it to 0, and we'll remove its double, 0. And so next time we get to 6, its occurrence would be 0, so we don't need to process it, right? And so what this would mean here is we need to check if the occurrence of the number is equal to 0. We can just continue, because that means it was a double of another element before and we removed it, right? And so we can just continue to the next element. Now if what if the double is 0, right? So what if, let's say, I don't know, maybe we had 3 before here, right? And so this was 2, this was 1, and then so we process 1 here first, and so this becomes 1, this becomes 0, and then we advance to this one. Its double is equal to 0, which means there is no double for it, right? Which means this is not a doubled array, because every element needs to have its double. And so if this is the case, the double is equal to 0, that means this is not a doubled array. So what do we do in that case? The problem says to return an empty list, so we do that. Okay? Now we append res, right? Because when we pass all of these, that means the number has an occurrence and its double has an occurrence, right? In a case like this, for example, which means we are good for this number. It is there and its double is there, so we can add it. What should we do next? Okay, and then we add it, but now since we processed this element, we need to remove it. And we also need to remove its double because we used it by adding it to the original here. So this is, maybe it will help to rename it original. So let's name it original here. Okay, and then we would subtract also the double, and we'll return the original. Okay, now there is one case, which is if the number is equal to 0. In that case, we need at least 2 of it, right? We need 2. Like, so if the number is 0, let's say maybe we have just this one. So we'll find that the occurrence of 0 is not 0. And so we'll proceed. We'll find that 2 multiplied by 0 is also not 0. And so we'll proceed here. But the problem is we have just 1 0. This is because 0 and its doubles are the same. And so we need to do a special case here for 0, right? So if number equal to 0, we want to have 2 zeros so that it doesn't pass through because with just 1 0. So we want to check that there are 2 zeros. And so we check if occurrence of number is actually, if it's smaller than 2, that means we had just 1 0, right? Or let's say if it's just 1 0, we want to say this is not a doubled array, right? Because for it to be a doubled array, when there is 1 0, we need to have 2 zeros. And so we return, if it's just 1, we return empty list. And that's pretty much it. So if we run this, Okay, our collections is lowercase. And let's submit. Okay, so this passes test cases. Yeah, so that's pretty much it for this problem. Now, in terms of time complexity, this is O(n) time here. We do at most n operations, but we sort, so it's O(n) log n here. We sort first because you can imagine also we do something like just to make it clear, we do something like this, and then we do nums.sort, right? So in that case, it's O(n) plus O(n) log n. So overall, it's O(n) log n. In terms of space, we are using this occurrence counter. So in the original array, so at most also O(n). So this is O(n) log n time and O(n) space. Yeah, so that's pretty much it for today's problem. Please like and subscribe, and see you on the next one. Bye.